Now that I've selected a unit, the next thing is to start plotting. But before you start plotting, please, you're expected to know the value of each small line, both on the vertical axis and on the horizontal axis. Because most times the values in our table, right, they fall on all these small lines. So it's important for you to determine the value of each of the small lines. And how do you get the value of each small line? So getting the value of each small line is simple. All you have to do is the unit you selected on any particular axis divided by the number of small lines between the chosen centimeter. We use 2 centimeters on both axes. So the number of small lines between any 2 centimeters, we have 10 of them. And you can always count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the next tick line will make it 10. So on the vertical axis, each small line will be what? Just for you to see. It's actually 2.5 because the unit we selected there is 25 units. So you're going to press 25 divided by the number of lines, small lines between the chosen centimeter. 25 divided by 10 will give you 2.5. So each small lines on this axis is 2.5. Let me indicate it. I will still wipe off because you're not meant to write on this marginal side. Okay, you're not meant to write there. Then on the horizontal axis, you do the same thing. The unit I selected is 6 units. Divide 6 by 10 small lines. That will be 0.6. All right, 6 divided by 10, you get 0.6. 0.6. So that's the value of each small line on this axis. So do you see? Always make sure you know the value of each small line before you start tracing your point. It is now time for me to start tracing all these points. And I hope you are ready. We shall be using this formula. Location of point in graph. Location of point in graph. LPG. Location of point in graph. I want to locate all these points, all these things you're plotting. I want to locate it in the graph. It is going to be equal to value to be located or to be plotted. Value to be located or to be plotted. You can write the meaning of all these things so you get used to them. Minus the unit it is taken from. Minus the unit it is taken from UT. Divided by the value of each small line. Value of each small line. You see, once again, location of point in graph. All these points, we wish to locate them in graph. We wish to present them in graph. So the location of any point in graph is equal to the value you want to locate or plot. That value, you get it from the table. I want to locate 187.5 now. Where will it be in the graph? So value to be located, all right, minus the unit it is taken from in graph. That unit it is taken from is in the graph. I'm going to give you a quick example. 187.50. If you come to the graph on the vertical axis, 187.50 is between 175 and 200. 187.50 is between 175 and 200. So since it is between these two visible units, that 187 from your table, the unit it will be taken from is 175. The unit it will be taken from is 175 because you will cross 175 before you meet 187.5. Since the 187.5 is between 175 and 200, the location of that point, 187.5, will be taken from the unit. Look at the formula here. So I will be evaluating 187.50 minus 175, which is the unit it is taken from, divided by the value of each small line along that axis, which is 2.5 if you remember. So let us do that and see. 187.5, which is the value I want to locate in the graph, the value I want to plot in the graph. 187.5, you know, 0.50 is still the same as 0.5, so I don't want to punish myself fixing that 50, that 0 there. Now, that is the value I want to locate. Then minus the unit it is taken from. Minus the unit it is taken from. That unit it is taken from is found in the graph. It is taken from 175, like I said. So it is going to be minus 175. All right. Now, this gave 12.5. I am going to divide it by the value of each small line along that axis. Each small line along that axis is 2.5. So 12.5, I am dividing it by 2.5. And what did I get? 5. What does this mean? The calculator is telling me now that 187.5 that I want to locate in the graph. Once again, 187.5 from the table, which I want to locate in the graph, is on the fifth line. On the fifth line, counted from 175. Remember, the unit is taken from 175. So I will go to 175 and count 5 lines above it. The line of 175 exactly, this thick line, since there is a unit there, we take it as line 0. The one above it will be line 1. This would be line 2. So we go, I hope you can say that. Line 1, 2, 3, 4, and 5. So this is the fifth line there. That is where 187.5 is. Now all I have to do is to go to the horizontal axis now, LO plus LI plus LO axis, and get the corresponding value of 187.50. On the horizontal, it is 42.5. So I'm going to look for 42.5 along the horizontal, LI plus LO axis. I'm going to look for 42.5. Look at it. I want to locate this point now. So all you just have to do here is to play with your calculator. Nothing is there. Using this formula. Location of point in graph is equal to value you want to locate, value you want to plot in your graph, minus unit it is taken from. Are you following, right? Value you want to plot from your table, minus unit it is taken from your graph, divided by value of each small line. So let us do it. 42.5. So it's going to be 42.5. 0.50 is same as 0.5. That's the value I want to plot. Minus which unit is it taken from in your graph? Let's watch. 42.5, between which two units will you see it? You'll see it between 42 and 48. So 42.5 is taken from 42. All right? The unit it is taken from is 42. Applying this formula, I'm trying to locate the value 42.5 from the table. I'm going to press 42.5, which I've pressed, minus unit it is taken from. Like I said, it is that 42.5 is between 42 and 48 in the graph. So the unit it is taken from is the smaller unit, 42. So this is going to be minus 42. All right. This gives us 0.5. Then divided by value of each small line along that axis. And each small line along that axis is 0.6. So I'm going to divide this 0.5 by what? 0.6. If I divide it, this gives me 0.8. Now this 0.8, you see, if you're talking about number of lines, the position of line where that point is located, each of these lines here, they are whole number because we counted them 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. For that reason, whenever you want to locate any point in graph, and you apply this formula, your calculator gives you decimal. Please make sure you do normal approximation. Normal approximation. 0.8 is equal to 1 if you approximate this to the nearest whole number. And if you are approximating to locate that point in graph, you approximate to the nearest whole number because number of lines are whole numbers. Are you getting me right? Number of lines are what? Whole numbers. So 0.8 is approximately equal to 1. What is the implication? It means that this point, this value from your table, 42.5, that I want to locate in the graph. Are you following? It is on line number 1, counted away from 42. Remember that this value is taken from 42. This 42.5, according to this formula, unit taken from, it is taken from the unit 42. So from what the calculator gave to me, which we approximated to 1, it means that 42.5 is on the first line, counted from 42. Now look at this thick line that is assigned 42 units. Is 0 line. The first line now is the next small line. So you start counting 1, 2, 3 in that order. And like I said, from what calculator gave to us, 0.8, if you approximate it, you get it on the first line here. I hope you can see that. I hope you can see that. Let me position this. Look at it on the first line. This line. This line. Good. So I have gotten where 187.5 and 42.0 where they are located. All I have to do is now to trace where both of them will meet. And this guy is a small line, so I'm going to use this ruler to indicate it. Okay? I'm going to use ruler to indicate it. Okay, now let me place this ruler here instead. Then I'll trace a vertical to meet it. I'll trace a vertical to meet it. So this is the line of 187.5. Now, the first line from 42, if you go up, this is 42 line. Look at it. So the first line away from it is here. Therefore, this is the point. This is the point, right? Where 187.5 and 42.5 meet. Let me indicate it properly. So at this point, I'm going to indicate it, look at it, and then I will circle. Let me circle it. Let me circle it. Make a point where the two lines meet, and then you circle it. So, dear friends, you see, this is how you select your scale and then plot your graph. You know, we'll talk about selecting scale and plotting graph. Selecting scale is for you to, know the unit you are using for a particular centimeter which you decide. Okay, then plotting now is where you start tracing all these points, and I've shown you how you go about it. This is a wonderful formula that should guide you to locate any point in your graph. And don't forget the value of each small line, very important. You notice now that this one we did fell on two small lines, you see. Remember all the formulas I gave you, you can replay the video. Now let us move on so I can locate the second point. After that, I will now complete the rest. Let's see what we have in the second point, 124.0 on the vertical axis, Li times Lo, 124. But if you come to the graph, 124 is not there exactly. 124 is between 100 and 125. So all you have to do is to apply this formula. Value to be located. The value is 124 from your table. Are you there? Minus the unit it is taken from in graph. Minus the unit it is taken from in graph. On the vertical axis, that 124 is between 100 and 125. Therefore, it is taken from the smaller unit 100. So it's going to be 124 minus 100. Then I'll divide it by the value of each small line. This gave me 24 when I subtracted. Then divided by the value of each small line. Each small line on that axis is 2.5. Okay, so let me divide by 2.5. And then see that this gave me 10. It gave me 10. Which means 124 will be located on the 10th line above 100. So you come to 100 and you count 10 lines above it. As a matter of fact, 10 lines above 100 is going to be exactly on 125. You can see this 100 line is a 0 line where that visible unit is shown 100. So you go 1, 2, 3. I hope you're following. 4, 5, 6, 7, 8, 9, and 10. So it is on the 125th line that you have your 124 if you are plotting this graph. Normally, someone may say that, okay, 124 will be between this tiny line. I don't know, I'm trying to show you this. That, okay, 124 will be between this tiny line and this thick line. Are you following, right? Because 124 is not exactly 125. That we understand. But it's important for you to know that you can't plot between the boxes, the tiny boxes. It's not done. This graph has been calibrated for you. So all your points are meant to be on a particular line. Yes, that's the principle. I hope I'm communicating right. So do not go and fix 124 in the box. Say, don't do that. It must fall on one of the lines, either the thick or the thin line. Feel free and indicate it. That's where your 124 is. Then let us get the corresponding value of the horizontal axis, which is our Li plus Lo. Look at it, 22.4. So how do we locate this 22.4 in our graph? This is the powerhouse. Value to be located minus unit it is taken from divided by value of each small line. So we are trying to locate 22.4. I'm going to press my 22.4 in my calculator. Then minus unit it is taken from. You go to the Li plus Lo axis. 22.4 is taken from 18 in this case, because 22.4 is between 18 and 24, between these two visible units. So the unit it will be taken from is going to be 18. Therefore, following this formula, value to be located in your graph, which in this case 22.4 minus unit taken from, which in this case is going to be 18. All right, so I'm going to do minus 18, and this gave us 4.4. Then remember to divide by value of each small line. Each small line along that axis is 0.6. You can see that. So I'm going to divide this 4.4 by 0.6. This is what the calculator gave to us, 7.33. If you do normal approximation on these to the nearest whole number, you get 7. And what is the implication? It means that our 22.40 that we want to locate in the graph is actually on the 7th line, counted from 18. So we go. Watch as I do the counting from 18. The thick line that is bearing the unit 18 is your 0 line if you're counting your line. So the first tiny line is line number 1, number 2, number 3, number 4, number 5, number 6, and number 7. So this is where the 7th line is. This is where the 7th line is. All right. At this point, I can now trace. This 124, which of course is the vertical value, 124. You can see that. It's already on the thick line, located at 125. So I don't have problem that I can see that line very clearly. But then the corresponding value on the horizontal, 22.4, fell on a small line, the 7th line. It's tiny. So I'll use my ruler and place it there, right? So that it can help me trace it quickly. Good. Then that corresponds to 124, which gave us 125 points here. Look at it. So this is where the point is going to be. That's where the point is going to be, here. So you take note of the points, and then you do what? You circle. I prefer using points and circling. Some might just use a cross like this at that point, no problem. Whatever your examiner asks you to do, you do it. All right, so let us move on. The next point is 150 on the vertical axis, right? Li times Lo axis. And of course, if you go to the graph, you have your 150 very clear there, so you don't have any problem tracing it. Let us get the corresponding horizontal value Li plus Lo. That is 25. Now, the horizontal, do we have 25 showing in the visible unit here? No. So we need to trace it using our formula. Value to be located in this case is 25. So I'm going to press 25 minus unit that it is taken from. If you come to the visible unit, 25 is between 24, right, and 30. So it's going to be 25 minus 24, the unit it is taken from, the smaller unit minus 24. Then we shall divide this by the value of each small line along that axis, which is 0.6. If you do that, this gives us 1.666. Approximate to whole number, that will be on the 2nd line, which means if I go to my graph, my 25 on the horizontal axis is going to be on the 2nd line, counted away from 24. All right, so this is 1st line and this is 2nd line. So all I have to do, you follow it up the 2nd line, right? Follow it up the 2nd line, then you go straight, see where it meets that of 150. I think that should be at this point. That is at this point. Make the point and then you circle it. Okay, let us see what the 4th point is like. This is 146 and it corresponds to 27.3 on the horizontal. So 146 on the vertical, let's see. In the graph, we do not have 146 in the visible unit. So I have to apply the formula 146, the point to be located or value to be located minus unit taken from, to be taken from 125, because 146 is between 125 and 150. Are you following, right? So to be taken from 125. So this is going to be minus 125. And then, of course, we shall divide by the value of each small line along that axis, which is 2.5. 2.5. And that gave us 8.4. If you approximate this to the nearest whole number, you get 8. And let me tell you, this position of line or location of point in the graph, since the number of lines between the chosen centimeter is 10, whenever you're doing this from your calculator, the highest value in terms of location of point in graph, the position of line where that point will be located, the highest value you can get is 10. It can't be more than 10. That is how unique this formula is. Yes, it will guide you. Be confident in using it. It can be more than it because the number of small lines between the choosing centimeter is 10. If it were to be 1 centimeter you use, and you apply all these principles I'm teaching you, between 1 centimeter you have 5 small lines. If you're doing all this calculation with your calculator to locate the point in graph, the line can never cross 5. The values the calculator will give to you in that case will not cross 5 because for 1 centimeter, you have 5 small lines. Our own here is 2 centimeters where we have 10 small lines. So you see, however, I'm trying to locate the point in graph with this formula. You can never get a point greater than 10. If you get a point greater than 10, then what you pressed in your calculator is rubbish. So you have to go and press the correct thing. Okay, let us move on. I think 146, according to the value from the calculator, if you approximate 8.4 to the nearest whole number, it is going to be exactly 8. So on the 8th line, above 125. So all I have to do is to come to the graph. Above 125, I will count 8 lines. So we go 1, 2, in fact, I can count it down from 150. 8 lines above 125 is the same as 2 lines below 150. You know, all these basic arithmetics we guide you so that if the number is closer to 150, are you following, right? You know where you start your counting from. But follow the formulas I gave you. Follow it. So 8 line. 1, 2, 3, 4, 5, 6, 7, 8. Here. Look at it here. Which is the same as counting 2 lines below 150. This line of 150 is your 0 line since you have a visible unit. So counting down, 1, 2. Still landing on line number 8 if you count it from 125. The calculation, no, they lie. So let us go. The corresponding value is 27.3, as I said rightly. So let us locate that on the horizontal. We do not have 27.3 exactly on the horizontal. We don't have it. So we need to use the formula and verify where that point to be located in your graph. So 27.3, we're going to subtract. That is located between which 2 visible units? 27.3. It will be between 24 and 30. So it's going to be minus unit taken from 24. So minus 24. And then we divide by the value of each small line along that axis, which is 0.6. This is 5.5. With this value, 5.5, you can decide to use line number 5 exactly. Or you decide to use line number 6. Because if you approximate this to the nearest whole number, you get 6. Since I've been using that normal approximation, I would work with 6 here. Line 6. But if somebody decides to use line 5, you commit no crime. And I'll tell you the reason. The reason is because 5.5 is exactly half of the 2 visible units where you have that 27.3. Okay, so if I count from 24, 1, 2, 3, 4, 5. If I want to locate the point on the 5th line, the choice is mine. But no, I wouldn't want to do that. I've told you follow normal approximation. 5.5 can be rounded off to 6. So the 6th line here, this is where you will locate your 27.3. So all I have to do is to trace. All I have to do is to trace. So for 146, we found it on the 8th line above 125. That corresponds to line number 6, right? It corresponds to line number 6. So I place my ruler to help me know this tiny line here, okay? And then we now have line number 6. I'll use my pencil and follow it up, okay? I can come here and count 1, 2, 3, 4, right? That 4th line will correspond. I counted 4 lines from 30 to the left. But you know that our counting is meant to start from 24 since the unit taken from is 24. Are you following, right? 6th line. Look at it. You follow. Follow it. You follow it. You can see it here. But I have my secret of counting. Either I count from the unit I took it from, I'll count it from the other bigger unit. So I've located that point. You can see how scattered these points are going. It's not funny. It's not funny. But hey, I have values and I have no choice. The same thing, you have values in your laboratory work. As long as the values are correct based on your experimental, work, use them and plot. That is why you just have to know how to plot graph. Know how to plot graph very well. And at least I have shown you all the principles, making graph plot in 1+1. That's the truth. If you use this principle, there is no graph you cannot plot. Whatever the unit is, you can select an accurate unit. I've shown you how to select your unit. At least for the first time on this channel, I decided to plot directly in GraphBook today so that all of you can learn from anywhere around the world. All right, let us move on. The last point is 160 on Li times Lo axis corresponding to 31.4 on the horizontal axis Li plus Lo. So 160, let's check. Do I have 160 in the graph? On the vertical axis, no. So you have to find out. 160 minus units taken from would be 150 minus 150. And then divided by value of each small line along that axis is 2.5. And then the location of the point, this is 4. It gave me 4. I don't know if you can see it. But of course, you have your calculator to follow along as I'm pressing. So this tells me that 160 is on the 4th line above 150. So all I have to do is to come to 150. The thick line of 150 itself is the 0 line in counting your number of lines. If you move above, the first tiny line is line number 1, the next number 2, the next number 3, the next number 4. So this is where you have your 160. It corresponds to 31.4 on the horizontal axis. There is no 31.4 visibly on the horizontal axis as a unit. So we'll have to use our formula to locate that point. Powerful formula. All right, so we move on. It's going to be 31.4 and then minus, of course, it's going to be taken from the unit 30 minus 30. And then we shall divide it by the value of each small line, 0.6 on that axis. And this gave us 2.33, which is approximately 2. So line number 2 counted away from 30. So I will come and then count 1 and 2. So this is where it is located. So all I have to do is to start tracing, my 160, the 4th line above 150. I've placed my ruler to serve as, a demarcation. Let me know where it is. And then 31.4 is on the 2nd line counted away from 30. So I'll just go to 30 straight. 30 is already this thick line. 2nd line, 1, 2. So this is where the point is located. And then I will circle. I'm done plotting this graph. Yes, I said I'm done plotting the graph because I've traced the point. And once you've traced your point, your problem is solved. All you now need to do is to join the majority of the point on a straight line to get your line of best fit. Here you have to make your decision.